welcome to Geoscientist. In this tutorial I'm going to show you how to estimate pore pressure and overburden stress using TechLog. So if you haven't joined my channel yet, so please subscribe to my channel, like and share with your fellow geoscientists so you get benefit from the experience I have. So let's start with estimating the pore pressure. For pore pressure and overburden stress, you would require the common logs, which is delta T compressional, sonic compressional, and shear sonic. Apart from that, for the overburden stress, you will be requiring density log. So these are the key logs for the estimation of overburden stress and pore pressure. I have uploaded I have imported the data. If you want to view how to import data in TechLog, you can go to my playlist in my YouTube channel and you can watch and learn how to import data. So let's get started with how to first of all I'm going to show you how you are going to do your estimate your overburden stress, which is one of the principal stresses. We have three principal stresses. One is overburden stress or the vertical stress, and the second one is the maximum horizontal stress, and third one is minimum horizontal stress. These stresses are required to during when you do your geomechanical analysis for a well. So you require these three stresses along with the pore pressure and certain other mechanical properties, which I will come to you on, in that one in some other tutorial. So to estimate overburden stress, just go to I'm going to estimate this for this T2 well. I have uploaded my imported my open hole logs, which is DTCO, DTS, GR. So these are the major, and the ROP as well. So these are the logs I'm going to use. So let's start. First go to your geomechanics tab, and in geomechanics tab there's a button which says overburden stress. Click this one and use this method, extrapolation. So this input window pops up. From here select T2 well, and in the middle area turn off this aliases and just stick with this families and select bulk density and drop it here on the data type assignment. So create. Now here comes your workflow manager, and from to you have to drop your data set here for which you are going to use or going to estimate your overburden stress. So here my data is in D2 in under this logs. So I'll drag and drop this logs dataset over here. See, now it filtered out the data and selected row B from there. Now you go to the parameters, and here in the bottom right side you see a circular sort of arrow. You click this one and your parameter selection will come into the portrait mode. It is easy to view. So from here you don't have to do anything. You just have to change this auto extrapolation method to yes. Double click here and it will change it to yes. Now you just have to press this, run the computation. So here your overburden stress has been computed. So it extrapolates the density to the surface, because sometimes we don't have density log from surface. So it extrapolates from the the first reading to the top of the well. So I'll just zoom in. First of all, I have to compress this one to see the whole well. Zoom in. See now, so it has extrapolated the density with the blue line from the starting point to the top of the well. So you can see the blue line is passing through all of the density. So at some points it is matching with your original density, at some points it is deviating from your original density. You can adjust this by grabbing this blue button and dropping moving it to right or the left, wherever you want. So I'll move just to the left and press play button again. So see, now it has like adjusted my density extrapolate curve with the actual density curve. So this is how you can play with this density extrapolate. By doing this, one thing happens over here, auto extrapolation, it changes it to no and gets the values from these buttons which I have just moved. I'll move this one to the bottom of the well and I'll hit play again. So now it's almost adjusted with my actual density, and in the background it has rerun the calculation of vertical stress. Now I have two curves, S vertical underscore extrapolation and overburden motivate extrapolation. So this is the vertical stress in psi and this is mud weight equivalent overburden stress. So this is the same, just one is in gradient, one is the gradient and other is the in psi. You just click over here and save variable. Okay, same for the overburden motor wave in ppg and save variable. So you come over here, so they are these logs which I just have estimated. They came into the new data set, which is logs underscore overburden. So we'll just move these from here to in your logs data set. Directly copy because sometimes there is a sampling issue. Some log data sets are sampled at different interval and some logs are sampled at different interval. As these logs are in the same well and I have used the density log, so it the estimated vertical stress and the density have the same sampling interval, so that's why I am going to do directly copy. So both these logs are here. I'll just delete this data set. I don't need this one. So always keep your project clean. This will help you during the whole workflow. I'll close this one. I don't want to save a workflow layout right now. So I'm going to close this for now. I don't want to save the workflow manager right now. Now the next step is pore pressure estimation. For pore pressure estimation, one thing important is you need to have calibration points during the whole geomechanics or the mechanical earth modeling or the wellbore stability analysis. Calibration is very important. Calibration without geomechanics without calibration is insanity. So always calibrate your curves. Whatever you are estimating, it should be calibrated with your actual data. So what I'm going to do, I'm going to import the pressure data for my reservoir interval where I have certain pressures within the well, actual pressures. So I'll import my pressures over here. So I have saved my pressure in CSV format. First of all, sorry, I have to save them in the CSV format. Here I have T2 pressures. So in the first column I have TVD in meters, and then pressure in PSI. So these are the depths and these are the pressures. So they are for like 3 reservoirs. So they will help me to calibrate my pressure with my reservoir second pressure. Save as CSV. CSV comma delimited. Save. Okay. Yes. Close this one. So now my pressures are in CSV format. I'll just drag and drop this on the TechLog main window. So this type of data import visit opens. So it is asking what is your data set and what are its units. First of all, what is the well name? I'll just select the well name from here. It is T2. Data set name, I'll give the data set name pressure. Now it's the basically point data. There are different type of data set types: continuous, interval, check shots, time depth, trajectory, blah blah. So there are a lot of data set types. So basically pressure are the point data set. So I select point data. It is importing the data from line 3. If you see, it is importing from over here. What is the variable name line? It is the first line. So variables are TVD and pressures, and unit is on line 2, meters and PSI. So my TVD is the reference here. So I'll just hit load to import buffer. So here I have my pressures, TVD and pressure. I'll just click on the pressure and hit this import button. So here are my pressures within our project tree. I'll just turn off this one. Now go to the pore pressure tab over here in the main bar. Click pore pressure and click pore pressure. Now these are the variables we require to estimate pore pressure. When your selection tabs are grayed out, so they are not like required, but if certain tabs are in white color, so they are the compulsory inputs. So first of all, I am going to give the vertical stress. Let's select T2, and here is my vertical stress which I just calculated. I'll drop it here. For shale indicator, I'll select gamma ray. For compressional slowness, I'll use compressional slowness or DTCO. So you want to put calibration points, you can drop them here as well. So I'll select pressure and drop it here. I'm going to create and drop my this log data set over here. So now I have my vertical stress as vertical, my GR, my DTCO. Now I'll go to my zonation tab. In zonation tab, I'll go to on the left side there on the bottom there is a global zonation tab. Click here. give the name of formation tops file which you inserted during data import. I'll select all and press this button, insert zone from the zonation log window. So all my formation tops are here. Now for the method selection, so as I'm going to use eton method, eton methods uses sonic and seismic velocities, resistivity and d exponent. So eton method, pore pressure can be estimated using eton method if you have these sort of log data. For bowers you need sonic or seismic as well. For throughout you need sonic and resistivity, but right now I'm using eton method, so sonic will work for me. Go to the parameters tab. So here's your parameters window. I'll just squeeze it here. So first of all, my value is T2, dataset logs, zone name, the top and bottom of the zone. Here the only thing you have to check the shale indicator. So eton method, what eton method does, it estimates the pore pressure in the shaly formations, and where there are non-shaly formation, it do not estimate the pore pressure. It just extrapolates from the top and bottom of that non-shaly formation. So if for example there is a non-shale formation sandwiched between two shale formations, so it will globally interpolate the pore pressure from the upper shale levels and lower shale levels into the middle non-shaly layer. So I'm not going to change anything over here. So going to the eton parameters. In eton parameters, I'll just change the sonic scale from semi-log to linear, and it has changed for all of them. Now there is a sonic factor and sonic exponent or eton exponent. You have to change these exponents according to your calibrations. You have to calibrate your pore pressure data. So once you estimate using these exponents, you look into your pore pressure. If it is matching with your like calibration points, then no need to change these. If you see there is small change or change in the estimated pore pressure or the actual pore pressure, then you can play with the back calculate the sonic exponent or the eton exponent, and you can change this value to calibrate your eton pore pressure with the actual pore pressure. So for now I know my eton exponent is around 0.89. So I'll use this for all formations. I'll fill down. So coming to sonic trend line, you need a trend line to show. Trend line is basically, this is the compaction line, normal compaction trend line. So the normal compaction trend line shows you where you have the overpressure zone, where you have the normal pressure zones. So you have to draw this trend line over your sonic data and the gamma ray. So if you have the trend line in your logs, you can use it as log input. If you don't have the trend line with you, you can just create it over here. So if I click this one, so I have 4 options: create, edit, listen and use log input. So I'll just go with create. If I have it saved in my project tree, I can use it as log input. I just use this create option. Now going to the non-shale parameters. So here you can see there are different options for the non-shale. I'm not using non-shale. There's the default value is no for non-shale method, and what it does, so if you just expand it and see, it will estimate the pore pressure from shale above. So you just differentiate or filter out the shaly formations and non-shaly formation. In the non-shaly formation, for suppose my KO1 is a carbonate, I can use from shale above, from shale below, average between shales, or I can just define certain value or pressure value over here. And when I select the shale above or shale below, then I have to give the pore pressure gradient from the above shale or the below shale, or what gradient you're going to use between the shales. For now, I'm going to just select non-shale method to global interpolation. So I globally interpolated all shale formation looking at the trend of the pore pressure. I'll fill down all the, use the same method. When I select the global interpolation, you see all of the other parameters went away. So I'll just click this option, enable disable automatic launch, because during the pore pressure estimation you have to tweak your parameters, so you don't have to click every time this launch button. If this enable disable automatic launch button is enabled or enabled, it will automatically like estimate the pore pressure or adjust the pore pressure during your tweaking of parameters. I'll just click this one and hit the launch button. So this window pops up, your output window pops up. It didn't calculate a pore pressure now because I haven't created the trend line yet. So first of all, I have to create a trend line. First of all, adjust the sonic scale. It is 240 to 40. Select the DTCO, press F4. F4 will open the properties. In the properties tab, in the horizontal axis, change this family to user, and select for the lower limit use 140, as sonic log is displayed in inversely. So lower limit is 40, 140, and upper limit is 40, just to display this sonic as inverted. Done, and I close this. Now it's 140 to 40. Now it is giving me a certain trend within the formations. If you look at there, so the formations which are moving towards the left, so these are basically shaly formations, shaly intervals. So the more the sonic is moving towards the left, so it is showing an overpressure zones, and moving towards the right, so the normal pressure zones. So I have to create a trend line. So first of all, I have to define which formation is shaly and which is non-shaly. So for that, I have this GR log, I have this GR baseline over here automatically defined. But I have to define the trend line. It will estimate the shale and the non-shales. So just select this GR, and over here in the left toolbox, select this purple line, trend line edit. Once it is selected, it appears here. You just go here on the log and press your left mouse button. So it will start generating a trend line. So I know if I select here, on the right is my shale, on the left of this trend line will be my non-shale. So I'll just go and draw this straight line. You can do it formation wise, and you can generate one trend line, straight trend line. When you go to the bottom, double click. So see, as I have already pressed this button, so it automatically calculated shale and non-shale formations. So if I haven't selected this button, I had to press this launch every time I am going to do something over here. So now I know these formations are the non-shale formations and these formations are the shaly formations. So what I am going to do next, I am going to define the trend line for my DTCO. I will click DTCO, the trend lines appear here. So I will just define my trend line, create a trend line over here. You have to tweak this trend line more often to calibrate. See, now my pore pressures have been estimated. This black line is over here is my normal pressure, hydrostatic pressure. This is my pore pressure. This is the vertical stress, and this is all in. These are the gradients in the mud weight equivalent, and this is your effective stress. Effective stress is basically vertical stress minus your pore pressure. Now, how do you know your pore pressure is? Now, the next step, you go to and uncheck this trend line. Now, to check whether your pore pressure is correct or not, what you have to do, you will go and your calibration data, you select this pressures and drop it over this pressures window. So my pressures are here now, so I just have to adjust the scale for the pressures. So pressure scale is adjusted. I'll just go and if you see, I already have pressures imported because I selected those pressure previously when I was entering the data set. I'll just hit F4 in pressures, and I'm going to the display options. I'll select red color so they are more visible, and I'll increase the size of the circle. I'll close this one. I'll just zoom it to see whether my pressures are adjusted or not. So it seems somewhat off from my pressure. If you look at the blue line, the estimated pore pressure is lower than my actual pressure, and if you look at the other one, another formation, it is also lower than the estimated one, and so I have to adjust those. So I have to play with my trend line or my eton parameters. If I may go to my eton parameters, and from here my sonic exponent or the eton exponent, I'll change these. If I do it to 0.91, and if I fill down, see, now it has changed a bit. It has moved closer to my estimated pressures. I'll use, if I use 0.96, fill down, for this formation we have to, or you can play with these parameters, eton exponent, or you can change your trend line. So what I'm going to do now, I'm going to play with my trend line and see if it helps me or not. So I'll just select this trend line and move it a bit to the back. So this can be extrapolated to this one. So this pressure is okay, this seems okay, so you just have to adjust this one. So this is my LO. I'll just go to this LO, and change its exponent from 0.96 to 1.2. Let's see how it works. So this is how you can play with your parameters to calibrate your data set. Or you can go to the non-shale method, and instead of global interpolation you can use from shale above and below this formation. This is how you can calibrate your pore pressure with your actual data. And once your pore pressure is estimated, suppose I think my pore pressure is okay. If I think my pore pressure is okay, I'll just go above here and select my ppr as eaten, and I've saved this variable. They save this variable. Okay, I'll save this ppr as normal. Okay, save these gradients as well, mud weight equivalent. All right, save variable, and your effective stress as well. Save variable. Okay, so all your estimated pressures are now in your project tree. You can check them over here. So this is how you estimate pore pressure in your well. So I hope you understood the whole method. If you have any confusion, or if you have any query or a question, you can ask me in the comment section. I'll try to help you out in this scenario and any scenario. So if you haven't subscribed to our channel, please subscribe, share and like our channel. So see you in the another video of TechLog. I'll be doing the tutorials, complete tutorial for the geomechanic estimation or geomechanical modeling for TechLog. So stay tuned with my channel. See you in the next video. Bye bye.